Hello dear students, today I will discuss about limit and derivative, chapter 13. Okay, limits is new for you for a study. Okay, so limit is very important for higher class mathematics. So here see that whenever we consider some function fx, just y equal to fx is a function. Suppose fx is a function, then just we know that if function is given, just like suppose x 2x plus 1, then it is clear that it's have some domain, and on the basis of domain we can say that this is a real function or complex function, etc. Here 2x plus 1, that is, this is defined for all the real numbers, so its domain is set of all real numbers. Sometimes the function is given in some interval domain as a interval. Suppose function is defined in interval 0 to 5, where x belongs to 5, maybe this type of function is given. So this is interval, this is the domain of the function. Means just in the given function there may be some point where function in the domain their function is not defined, just like so we indicate that point the function x is equal to not that and so on, but we can find approximate value of that function. Suppose fx equals to x square minus 1 upon x minus 1. Just you have to write like this because it is not defined at x equal to 1. Just we can see here numerator will be 0, denominator will be 0, 0 by 0, but 0 by 0 format, if function is defined like this, x square plus 1 upon x minus 1, suppose, then x equals to not 1 also, because x equal to at 1 denominator is 0, that is tending to infinity, that is not defined. But here in this case also denominator is 0, but numerator is also 0, so this is meaningless. But here function is not defined. Okay, but in this case we can approximate the function, because at all real numbers function is defined except 1. So where what may be the approximate value of function fx at the point 1? For this purpose, just we have to find limit. Here also we can try. Limit from whenever, here what? Here we see that its domain having real numbers. Real number from minus infinity to plus infinity. Here is 0, this is negative number, this is positive number, and so on. Clear? But at this point 1, it is not defined. So we can try to find its value. How? Because at each point its value exists. At each point its value exists. So we can see that as x, because x lies in this line, so as x approach to 0 means just we can find the value of this function by putting x equal to minus 2, x equal to minus 1, x equal to minus 0.5, x equal to minus 0.2, minus 0.1, and just we can go from left side to the point 0. Point 1, 0.5, 0.7, 0.9, and so on. Here, x tending to 1 from left side. And also, we can see that we can go to the point x equal to 1 from right side also, for decreasing the number. Therefore, x equal to 3, we can find the value, and x equal to 2, we can find the value, x equal to 1.5, we can find the value, x equal to 1.1, we can find the value, and just tending to 1 from right side. This is from right side, this is from left side. This we can go to the point 1. So we can see the trend, the value of the function, the value of the function, the value of the function, also the value of the function. So by observing the value of the function, we can see that function tending to some value, function tending to some value. If both values are same, then we can say that limit exists. If both values are not same, then limit does not exist. From left side, whatever be the value fx tends or approach, called left hand limit. And from right side, whatever be the value to which function approach, that is called right hand limit. Okay, so left hand limit and right hand limit of fx. Limit x tending to 1, left limit. Limit x tending to 1, right hand limit. Okay, if these two are equal, separately exist, and is these two are equal, then we can say the limit exists and limit is that. Okay, so here how can we find the limit? Also, whenever denominator is 0 and numerator is also 0, 0 by 0 forward, so we can try to factorize numerator and denominator and cancelling the common factor, and then just try to find the value as a definite value if we can get. Just like find x tending to 1, limiting value not at equal, okay, x is not equal to 1, fx. So we can write what? Limit x tending to 1. It means what? Limit x tending to 1 means as x approach to 1, as x approach to 1, just go through from left side or right side maybe, okay. So as x tend to 1, that is called limit. Limit x tending to 1 means what? As x approaches to 1, as x tends to 1, the value of function is what? Okay, so just like this. X square minus 1 upon x minus 1. Okay, here. So we can see that here 0 by 0 format means denominator is 0 and also numerator is 0. So just we are trying to, because this is a polynomial function, this is a polynomial function, numerator and denominator having some common 0. So here what is this? So just you have to factorize both. So denominator is already one linear factor and numerator can be written a square minus b square formula. So x minus 1 into x plus 1. Now as x tending to 1 is approaching to 1, that is x is not equals to 1, so we can cancel out these two because they are not 0. So limit x tending to 1, x plus 1. Now for finding limit, that is very simple. Just if we put x equal to 1 at approximate, but we put x equal to 1 in this place, if you get definite value, that will be the limit. You can write just as a substitution. Okay, so here we see that in place of x, 1 plus 1 equals to 2. 2 is the limit. So its limit is 2. Limit means as x tending to 1. Approximate value. Because just in the function, if we put x equal to 1 and x equal to 1, so 0 by 0, this is not meaningless. But after solving, cancelling, because limiting value, the tending value, not at equal, because not at equal, not x equal to not 1, that's why we can cancel out these two quantity. And finally we can get 1 plus 1 equals to 2. That is the limit. It is called limiting value. So limit x tending to 1 fx equals to this. It is also write like this: fx tending to 2 as x approaching to 1. Just we can write also. That is fx approaching 2. Fx approaches 2 as x approaches 1. Clear? So from both sides we can also see here, from both sides. That means both side means just here consider how we get left hand limit and right hand limit. Suppose we are giving its value, just we see that because x is not equals to 1, that's why we can this can be written as x equal to not 1, as x equal to not 1. As x equal to not 1, so we can write it x minus 1, x plus 1 upon x minus 1 and equals to x plus 1, x equals to not 1, x equals to not 1, x equals to not 1. Okay, so this is fx. Clear? X equal to not 1 in this case. That means for x equal to 1, now we are approaching x to 1 from left side and right side. Left side means, just consider, if we give the value of x, because we cannot put x equal to 1, so if we put value just slightly greater than 1 value here, then its value will be slightly greater than 2, because it is greater than 1, just slightly. So greater than 2, slightly. And also if x is less than, slightly less than 1, then its value will be slightly less than 2. So just see if from right side, from right side of x, that is x equals to 1.1, x equals to 1.01, x equals to 1.001. Okay, this is greater value, greater value, greater value. That means from right side means x tending to 1, this is 1, x tending to 1, this is 1. So 1.1 may be here, 1.01 here, 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 just right. We go to like this. X equal to 1, x this and so on up to x equals to 1. Just so we can get the value of function as what? Here fx. Fx equals to what? X equal to 1.1, so 2.1. Fx equals to this 2.01. Fx equal to this what? 2.001 and so on. Fx equals to 2. Tending approximation. So just 1.1 then 2.1, 1.01 then 2.01, and this value has a trend 0.00000001 means tending to 0.2 from right side. So we can say that as x approaches from right side, that is x approach 1 from right side, x approach 1 from right side, fx, this is equals to 2. That is fx approaches 2 as x approaches 1 from right side. Okay, this is right hand limit. This is right hand limit of fx is equals to 2. So this is right hand limit, or right hand limit. Okay. Similarly, just we can approach from left side, from left side of x. Just x equals to 0.9, x equals to 0.99, x equals to 0.999 and so on. Just and here fx equals to what will be the value of fx? X plus 1. So what? 1.9 fx 1.99 fx 1.999 and so on. Just we can get value and approximate value what? At this one 2. Just we can see the trend 1.9, 1.99, 1.999 and so on, so on, so on. So what? Trending value, approximate value, just like 2. So here this is left hand limit equals to, just we write like this, x tending to 1, minus sign is there. This is x approaching 1 from left side. Fx is equals to 2. Left hand limit. If these two limit exist and equal, here we see that equal, so limit exists. That is, if left hand limit and right hand limit exist, then we can say the limit exists. maybe left hand limit and right hand limit both separately exist but not equal, then we say that limit of the function is not exist. Okay, so this is the definition of left hand limit and right hand limit. Okay, so we can use for solving questions. If limit exists, that means both limit, right hand limit and left hand limit exist at a particular point and both are equal. Okay, maybe limit, left hand limit and right hand limit both exist separately but not equal. Okay, so limit x tending to a, left hand limit x tending to a, right hand limit. If this, then we say that limit of function fx at the point x equals to a exists. If left hand limit minus sign, right hand limit minus sign of the function fx at the particular point x equal to a, if this left hand limit, right hand limit equal, then we say that limit of the function fx at the point x equal to a exists, and we write limit x tending to a purely, not plus sign, not minus sign, equals to okay, L is a limit, left hand limit and right hand limit both equal and equal to L. Then we can say that limit, pure limit exists and that is equals to L. Okay, so this is the definition for finding limit. Now, how can we find limits of different functions? What is the rule for finding the limit of the function? Just see here, a very simple technique. Whenever we can get a definite value by putting the value a for x in the function, that is the limit. If we can get definite value. If we cannot find definite value by putting x equal to a, then we will try to reducing the function. Suppose function is in terms of fraction. Generally, if we are having fractional, rational function you know, fx by gx. Okay, just before that, we want to discuss about some special formula for finding limit. Here, just see. First rule is this. Just first rule. What is the first rule? First rule is finding limit of a function. Finding limit of a function. Okay. Rule 1. First, if we can get a definite value by putting x equals to a in function, then that value is limit. Okay, if limit extending to a fx we want to find, then if we can get a definite value by putting x equal to a in function, then that value is limit. Just like suppose limit x tending to 2x plus 1 by 3, this is function. Just put the value 2 into 2 plus 1 upon 3. So what? 4 plus 1, 5 by 3, 5 by 3. This is just like as a value of the function at that point. If we can get definite value, that is the limit. Okay, very simple rule, first rule. And second rule. Second rule is here, just rule second. If function is a rational function means just like this, fx upon gx. Rational function means fx upon gx. Rational function, that means our given function just like this, fx equals to 2x upon 5x plus 1. This is rational function. This is rational function. This is fx and this is gx. So rational function, we can write like this. Suppose rational function, if numerator and denominator having some common factor, for that just you have to factorize this and you have to factorize this. After factorization, if we see that there are some common factors in both, then just cancel out that factor from numerator and denominator. If rational function, and just factorize numerator and factorize denominator, and there are common factor, cancel out that factor, and then put x equals to a. And if we get definite value, that is the limit. Okay. And here 2-3 things are important. If, just write if function is rational function, then factorize the numerator and denominator. If function is rational function, then factorize the numerator and denominator. If denominator, if there is any common factor, then cancel them from numerator and denominator. If there is any common factor, then cancel them from numerator and denominator, and finally put x equals to a in the remaining part. Or find the limit. Okay, so this is second rule. In this case, just suppose, let if again, just understand what is the process. Again, if here after cancellation, just like suppose again, if after cancellation, denominator is 0 for x equals to a, then accept numerator. Accept numerator if denominator is 0. If after cancellation denominator is 0 for x equals to a, accept numerator, then limit does not exist. Okay, that means just we can understand if this is rational function fx by gx. Okay, just factorize it. If for a particular value, suppose x equal to 1, if suppose for x equals to a, just we factorize this common factor. It's if common factor x minus a, it's also a common factor x minus a. That means numerator and denominator will be 0 for x equals to a. Just like our previous questions, what x square minus 1 upon x minus 1. Here what factor? X minus 1 is factor, here x minus 1 is factor, x plus 1, like just like this. Common factor are there for 1, here a. If both are 0, that is 0 by 0 form, if 0 by 0 form for a particular value of a, that means f a g is 0, that means what? A is 0 of this polynomial, that is it's have a factor x minus a, so we can factorize this. If numerator having factor of degree 1 time, 2 time, 3 time, suppose k times. If denominator having this factor up to l time, having factor, and this will be 1 after factorization. Now these two factor, if k and l are equal, then we can cancel out. If k is greater than l, that means just denominator l, we can write k minus l. So k is greater than l, that means there will be some factor in the numerator and denominator will have no common factor of like this. So this will not be 0 for x equal to a, and numerator will be 0. So 0 by definite value, that is limit 0 if k is greater than L, and if k is less than L, that means there will be a factor in denominator but not in numerator. So numerator will be definite value and denominator will be 0 for a, so not defined. In this case, not defined. If denominator is 0, denominator is 0, not defined. This is finite, but it is 0, not defined. And if this is 0, but this is not 0, denominator definite value, then limit 0 in this case. Okay. So use this rule. Just like for factorization, here x square minus 9 upon x minus 3. So limit x tending to 3, because at 3, 0 by 0 form. So we can cancel out x tending to 3, x minus 3 and x plus 3 upon x minus 3. So 1, 1, k equal to 1, L equal to 1, both are equal. That is k is greater than or equal L, then limit can be found, because this to cancel, x plus 3, so limit x tending to 3, x plus 3 equals to what? 3 plus 3 equals to 6 is limit. Okay, limit is 6. So we can find this type of factorization. Also, this is a polynomial, this is a polynomial, just factorize and cancel a common factor. If denominator is having 0 after cancellation, then limit will not exist. Okay. Now third rule is if limit a function having third sign, that is root sign, then just remove if rule third if function having short sign, shorts means square root. Okay, if function having shorts, that means root over something plus minus, then simplify by using conjugate shorts, and then put x equals to a. Clear? That means just like function, suppose root function is just like this, root x plus 1 minus root x plus 1 upon x. Clear? And x tending to 0. Just we are trying to find this limit of this function, x tending to 0. That is limit. The short sign. So generally we are trying to just, you can put here 0, x equal to 0, x equal to 0, that is upper side, the denominator will be 0. I'll also here denominator will be 0. So 0 by 0 meaningless here. Okay, 0 by 0 meaningless. if we put x equal to 0. So in this case, just we have to use for short sign its conjugate. We know, just like rationalization process, what we can say like this: fx equals to root over x plus 1 minus root over x plus 1, not x plus 1, sorry, x 1 minus x. Here 1 minus x. 1 plus x and 1 minus x. Just take like this. 1 plus x and 1 minus x. Okay. Plus and minus sign is there. Okay. 1 plus x and 1 minus x. Both are having 0 by 0. So its conjugate means plus sign in this place. So root over 1 plus x plus here minus sign, here plus sign. Root over 1 minus x. Okay. Just use in numerator and denominator. Having shorts, then simplify using conjugate shorts. Conjugate means its opposite sign. Just take and multiply numerator and denominator. Then we can see that what? A minus b, a plus b. A square minus b square. A square means root will cancel over 1 plus x minus of 1 minus x. A minus b, a plus b. A square minus b square. Root over square, root over square. Then cancel out. Okay. So what we will get? Just we can write here x into root over 1 plus x plus root over 1 minus x. Okay? And then this is equals to what? 1 1 cancel, minus minus 2x. 1 1 cancel, 2x upon x, x cancel 2 upon root over 1 plus x plus root over 1 minus x. As x tending to 0. So not x equals to a. As x tending to 0. Okay. X tending to 0. X tending to 0. Not equals to 0. X tending to 0. Not equals to 0. So x tending to 0. Just now we can use. Put x equals to 0. Because 2 upon root over 1 plus 0 plus root over 1 minus 0. So what? Root over 1, 1, 2, 2. 2 by 2 equals to 1. 1 is the limit. Clear? 1 is the limit. Here what main thing is? Short sign is there. So just use conjugate and solve it. And finally you can get put x equals to 0 here for finding definite value. Okay. So x cancel out. That's why you can put x equal to 0. So this is limit. So this is third rule. And fourth rule is that if you know about series, if you know about series of some special function, just like our function contains sine, tan, exponential function e to the power x, then you can use series for finding limit. Okay. So some of the special series are there. So just remember all that series. Okay. Just like here, we know if function can be represented as an infinite series form in numerator and denominator, then we can reduce the given function in a form that can give definite value by putting x equals to a. X equals to a. Numerator and denominator we can express as a series. Numerator and or denominator can be expressed as a and or, because maybe one in a 1 plus there is series, then you can reduce the function in a form that can be can give definite value. Just for example here, just the exponential series. What is exponential series? Some of the series, some of the series are as follows. What? 1 plus x square upon 2 factorial x cube by 3 factorial plus and so on. Sin x, cos x, log 1 plus x, binomial theorem 1 plus x to the power n, and etc. There are different type of series. So just the series are useful for finding. Just remember this series. Okay. So very important, because they are used. You can use directly in questions for finding limit. Okay. Sin x, what? X minus x cube by 3 factorial plus x power 5 by 5 factorial, and like this. So from this series we can get some special formula directly, or also in a particular questions, just you can express as a series form and then just put the value of x after cancellation, then you can get a definite value, that will be the limit. Okay, so remember all these formulas, very important. Okay, so a special formula sin x by x turning 1 can get by using this series. Okay, so these series are very important. Just like this, suppose these are the series expansion of sin x and e to the power x. So from here we can get formula just like here e to the power x minus 1 upon x, limit x tending to 0. Okay, so this formula can also see here. Series expansion, this from this series expansion, just find this limit. This is rational function. X equals to 0 here, 1 minus 1, 0, 0 by 0, 0 by 0 form. 0 by 0 form. So meaningless. So we can find its limit. Here, just we know its series expansion e to the power x, just like what? Limit x tending to 0, just use the series expansion. E to the power x. 1 plus x square by 2 factorial plus x cube by 3 factorial plus and so on up to infinity. All the terms containing x. minus 1. This series expansion, and here x. Now here we see that this up to infinity minus 1, this 1 and this 1 will cancel. So we can write limit x tending to 0 like this. Here we see that 1, 1 cancel. Then x is present in all terms, so x can be taken common. So we get 1 plus here 1 x will reduce. So x by 2 factorial, x square by 3 factorial, and up to infinity upon x. So 1x may be cancelled out because x tending to 0 not equals to 0. So this is equals to what? Limit x tending to 0. Now 1 plus x by 2 factorial plus x cube square by 3 factorial plus and so on up to after first term, each term will contain x. So just you can put x equal to 0. So all term will be 0. So this is equals to 1. So this limit is what? 1. The standard formula also. So series can be used also. This is the fourth technique for finding limit. Okay. So note down all these important formulas and write all series also and formulas in your copy, and try to solve some questions from examples, and also try different type of questions related to limit at the initial stage. Just you can use other book also. So do some of the questions and send me some of the formulas, your written formulas and questions for your attendance. Okay.